In mathematics, trigonometric identities are equalities that involve trigonometric functions and are true for every value of the occurring variables where both sides of the equality are defined. These identities are useful whenever expressions involving trigonometric functions need to be simplified. An important application is the integration of non-trigonometric functions. A common technique involves first using the substitution rule with a trigonometric functions and then simplifying the resulting integral with a trigonometric identities. This will be further discussed in the later chapters. There are quite numbers of trigonometric identities, such as opposite angle identities, double angle identities, angle sum and different identities, and half angle identities. If you are curious on how these identities are formed, you may look up through Google on your own. At this point of time, you need to know on how to use it in solving your problems. These formulas will be given during your examination. As mentioned earlier, the trigonometric identities are useful whenever expressions involving trigonometric functions need to be simplified. As what you can see on the left part of my presentation, the author tried to show that left hand side is equal to right hand side. Based on the solution given, the author manipulate the terms that occur on the left hand side and then show that towards the end it is equal to right hand side. So what I'm going to do right after this is quite different compared to what you have in the presentation, which is I'm going to show that right hand side equal to left hand side. So from right hand side we have 1 minus sine theta over cosine theta. Okay, let me write the question first. Show that cosine theta over 1 plus sine theta equal to 1 minus sine theta over cosine theta. Therefore, from this right hand side, I know that I have to multiply the conjugate of the numerator, which is multiply the conjugate, I will have 1 plus sine theta over 1 plus sine theta, as if even though we introduce new term, which is 1 plus sine theta, it won't bring any effects to the original expression, which is 1 minus sine theta over cosine theta. And then I will get 1 minus sine squared theta divided by cosine theta times 1 plus sine theta. So let us recall one of the trigonometric identities. We know that from trigo identities, cosine squared theta plus sine squared theta equal to 1. Therefore, cosine squared theta is equal to 1 minus sine squared theta. Then 1 minus sine squared theta is equal to 1 minus sine squared theta over cosine theta times 1 plus sine theta equal to cosine squared theta over cosine theta times 1 plus sine theta. Then we will get cosine theta over 1 plus sine theta, which is obviously right hand side equal to left hand side shown. Now let's try the question listed in the slide presentation. So I'm going to show to you how to verify tangent theta plus cotangent theta equal to 2 sine 2 theta. So right now I'm going to approach from the left hand side, and then I'm going to show that left hand side is equal to right hand side. From left hand side, tangent theta plus cotangent theta. This can be translated into tangent theta plus 1 over tangent theta. We know that tangent theta is sine theta over cosecant theta plus 1 over sine theta over cosine theta. And then you will get sine theta over cosine theta plus cosecant theta, not cosecant, cosine theta over sine theta. Since they don't share the same denominator, so we are going to perform cross multiplication, and then I will get sine squared theta plus cosine squared theta over cosine theta sine theta. Okay, this one times this one times this one, and that one. And then from here, I know that cosine squared theta plus sine squared theta equal to 1. Therefore, the numerator will become 1 over cosecant theta, not cosecant theta, I beg my pardon, it should be cosine theta sine theta. And then if you look carefully on the right hand side, there is 2 at the numerator part on the right hand side. So what should I do? I have to introduce 2, and at the same time I don't intend to change the question. So I will get 2 over 2. So from here I will get 2 over 2 cosine theta sine theta. Then from trigonometric identities, obviously sine 2 theta equal to 2 cosine theta sine theta. Then from here I'll get 2 over sine 2 theta. Therefore, left hand side is equal to right hand side, and then verify.